So if you're in this session, I think that we can agree that phenology matters and that we need to better constrain it through cross-scale data integration. But I have a wild assertion for you. We can do better. So plant phenology, or the timing of vegetation activity, is of the utmost importance across a whole host of disciplines, everything from agricultural output to carbon cycle modeling. And plant phenology has been undergoing an ecological data revolution. We now have ever-increasing data with which to hone our understanding. The last decade has seen the rapid expansion of in situ campaigns, both citizen science-based and experimentally designed, such as the National Ecological Observatory Network, or NEON. The past decade has also seen the deployment and expansion of digital repeat photography networks, specifically phenological cameras, or phenocams. Phenocams are mounted cameras that take pictures every half hour to every day. And through stacking thousands of images, phenocams can extract metrics of relative greenness from different plant functional types and allow us to quantify phenology via near-surface remote sensing. The phenocam network alone now includes over 800 cameras and almost 3,000 site years of data. For context, if you were to print all of these images and stack them upon each other, they would reach higher than Mount Everest, or would constitute approximately 30 Empire State Buildings. Concurrently, we've seen progressively complex algorithms applied to satellite data to capture vegetation dynamics and improve the spatial resolution of remotely sensed indices of phenology. So a veritable ocean of phenological data now sits at our computational fingertips. But the question is, how should we compare or integrate these data products that span scales from the leaf to the globe? These data differ on timescales, spatial footprints, and proximity to the ecosystems or processes that they observe. To navigate this sea requires tools that allow us to peer beneath the surface, compare various data sources, and understand how they can truly integrate. So hopefully I've only given you a mild panic attack about the amount of phenological data out there, and I've barely scratched the surface. But I have great news, and that is that over the last 2 years, I've been working with a really talented team to build a suite of tools to help you do better science, the Advanced Phenological Information Systems. And this is a suite of connected and communicating open source tools that span from R packages all the way up to Shiny apps to Google Earth Engine scripts to help you do better science. The component that I've been working on is called phenosynth. It's focused on marrying MODIS, Landsat, and phenocam data to optimize our integration of those data across scales. And as with all other open source tools and packages, I am where I am because of standing on the shoulders of giants, of other open source software engineers, of open APIs and open data, and all of those people deserve credit. So here's phenosynth. You can search by network, say you're interested in neon. You can hover and see where those phenocams are. You can view some metadata. You can also search for specific phenocams that you're interested in, for example, Bartlett. Once you click on that site, you can see the phenocam field of view relative to MODIS pixels, which is incredibly important, along with really essential metrics like MODIS land cover and NLCD land cover. You can select which data you want to work with so that you can explore it. And you can iteratively select individual pixels so that you can compare them and look underneath the hood to look at things like landscape heterogeneity. You can then plot the data for further investigation. In the plotting tab, you can hover over things like transition dates. You can look at metrics, heterogeneity metrics, for example, agreement between Landsat and MODIS land cover. And you can download the data for your own analysis at a later date. So phenosynth, what I've presented, is our first attempt at taking a big bite out of this data deluge and helping inform our science and our cross-scale comparisons between MODIS and phenocam. But talk is cheap. Where's the code? Hopefully I've whetted your appetite and you're interested in playing with phenosynth or the APIS suite. Here's a link to our GitHub. It's all open source. It's all there. We also have a NASA Bitbucket with a full suite of all the APIS tools. And we believe, and we want to assert, that to navigate these seas requires not the minds of a few, but the minds of many. And so I want to encourage you to go clone the app, to go fork it, to help improve it, and to help us all do better science and constrain phenology better. Thank you so much for your time.